Hey folks, Matthew Fab here with Western Washington Weather, and today I'm going to try to answer a question that I've heard a lot over the past few years, and that question is, why is it so hard to get lowland snow in Western Washington? And why are some of our snowstorms so rare, and when they are rare, they're really big? Like this photo, February 2019, many of you probably remember that was our last truly huge widespread snowstorm. In the years since, we've had some big snows, but it is usually a little bit more localized, or some areas get nothing while other areas get large amounts. So I want to answer some of your questions and show why it is difficult to get lowland snow in Western Washington. So it all starts with the polar lobe, and I know you've heard this term probably before on my channel, on other channels, and the polar lobe is basically an area of cold air that comes off the polar vortex near the North Pole there, and then moves south across parts of Canada, and then gets close to the Pacific Northwest. And one thing to look at here, so we have three scenarios, and the polar lobe's track is really what determines if we can get snow at all. In the purple scenario here, you can see where that polar lobe will track mainly inland, will not go out over the water at all. This will just bring a lot of cold temperatures to Western Washington, to Eastern Washington as well, but there's no moisture for it to work with because it stays over the land. You take a look at this red line here. This is the ideal scenario for a good lowland snow event across Western Washington and even parts of Western Oregon and into British Columbia, when you have the polar lobe that moves down across the cold continent, then moves out over the ocean, but only for a brief time, and then moves back over land. And if you get it a little bit further to the east here, this same thing can happen. This is the ideal track because you allow it to pick up some moisture, but not modify the air so much that it gets too warm when it comes in. And then you have the blue scenario over here, and this is where the polar lobe goes a little bit further offshore and never really makes it inland. And this is when you get some of those more marginal snow setups where some areas are getting rain-snow mix, some areas are getting snow, and it depends on your elevation, or a lot of other very tiny factors come into play because the polar lobe is not in a good place. So that is polar lobes explained and how they impact our lowland snow. Now let's take a look at a few scenarios. So this is scenario 1 with widespread lowland snow, and you can see when this scenario happens, you have that polar lobe that moves just over the ocean for a little bit and then moves inland. Ideally, you want that low to move inland, moving to the southeast, and you want it to move in mainly between ocean shores and the northern Oregon coast, and that allows an area of moisture called a deformation band to spread up across Western Washington all the way toward British Columbia and bring hours of steady lowland snow. And usually you want this to happen when you have some nice outflow out of the Fraser River Valley, which brings some cold air across the region and allows everything to fall as snow. A good example of this here is February 8th to 9th, 2019. You could see we had almost this exact setup. You had Arctic high across parts of British Columbia, and then you have this low right there moving in by Long Beach and Astoria, and that spread a nice deformation band across the region that brought hours of heavy snow to Western Washington on February 9th, 2019 there. Now, scenario 2 here is the Arctic front. So sometimes you have this cold air spilling out of the Fraser Gap, and it will push a band of snow on the edge of it because it's colliding with warmer air as it moves south, forming a frontal boundary with the snow. And then that just pushes south across the Western Washington lowlands there, especially right down the I-5 corridor. Some of Seattle's biggest surprise snow events have happened with an Arctic front setup like this. They can hit super fast, cause a super quick flash freeze, and can cause massive chaos across the area. This is a little bit more rare. Usually happens when you have a pretty strong Arctic outflow there out of British Columbia. But a good example of this recently is this radar loop from December 26th, 2021 there, and you can see how this snow band just slowly pushes south across from Seattle down toward Tacoma there in this radar loop. This was an Arctic front. It brought me 6 inches of snow in Federal Way, and that was kind of unexpected because it was more likely that it was going to go really fast, but it got hung up a little bit and started producing a lot of snow. So that's the thing with these Arctic fronts, is that they are sometimes hard to predict and that you don't really know how long they're going to last. But there is another scenario here. So this is scenario 3, the marginal setups. So you have this cold Fraser outflow, but it's a little bit more limited. So you don't get these northerly winds cooling down the air, bringing that Arctic boundary down towards Seattle and Tacoma and Olympia. Instead, you have a less optimally placed low, usually a little bit further offshore, which spreads hard-to-predict showers across the region, which can tap into cold air to bring localized areas of snow. Like you can have a lot of snow in the northern Olympic Peninsula along the Strait of Juan de Fuca, where that cold air meets the showers, and then you can have just splotches of snow across the metro area, but it doesn't affect everywhere, and it can be pretty hard to predict. You can kind of think of this like trying to predict where thunderstorms will move in the spring. You don't really know where it's going to come in, so you just kind of have to make your best guess on where those thunderstorms are going to set up in the spring. This is a similar scenario. You just kind of have to make your best guess on where those showers are going to move through, and that could bring some snow. And a good example of this is actually going on as I make this video, early February 2025 here. You can see this is not an optimally placed low right off Vancouver Island, but see all these showers it's spreading up into western Washington? This is bringing some areas of localized lowland snow, while other areas just a few miles away get nothing. And that is what happens in these type of marginal setups. So, some other key ingredients for lowland snow that you may hear talked about: cold temperatures aloft, usually measured as 850 millibar temps, and that just means temperatures at about 5,000 feet. You can also get temperatures, the 500 millibar temperatures, which are about 18,000 feet. And these are just metrics that talk about how cold the atmosphere aloft is, and the colder this is, it allows for showers to fall as snow, since the air they're tapping into is extremely cold. So if you think of like the air at the top of the clouds, the top of the shower, as that gets kind of pulled in and mixed down in the shower, the colder that is, the more likely it is that it will fall as snow instead of rain. Another thing you want is that Fraser River outflow, that cold northerly winds out of the Fraser Gap in British Columbia there, which is east of Vancouver. And that allows western Washington to be influenced by this Arctic air and keeps cold air in place as the snow starts to move in, which forms those deformation bands we talked about earlier. And of course, you want temperatures to be at or below 32 degrees. Lowland snow can mix in with the rain as warm as 36 to 37 degrees, but it usually won't accumulate unless it's very close to or below freezing. And usually, the closer it is to freezing, like if it's snowing and it's 30 to 31, maybe 32 degrees, you can get some really heavy snow with that. You can see this photo in the background of this graphic here is at my house in February of 2019 in that major snowstorm. It was only about 28 to 30 degrees as all this snow was falling, and you can see just how heavy it is and how it just stuck to everything. So these are just a few of the ingredients for lowland snow. Obviously, there are a lot of little microclimates and different areas, different winds, and a ton of other scenarios that can happen, especially when you have very cold air and then you get a big warm system moving in, but that cold air gets trapped at the surface, and then you can get an ice storm. That's extremely rare. It only happens once every 10 to 20 years or so in a major way for western Washington. Sometimes you can get a more localized type of ice storm or freezing rain event, but that is one of those more rare outcomes that doesn't usually happen when we have a lowland snow event. So I hope this video was helpful to you in getting a better understanding of some of the things needed to produce lowland snow. If you'd like to follow along with me and to get more updates about western Washington weather, you can subscribe here on YouTube and ring the notification bell and like and share this video. You can also follow me on Blue Sky, on the Western Washington Weather Facebook group, and on Twitter or X. All of the links to these are in the description. So I hope this was helpful, and I will talk to you all at some point.